Hello dear programmers, how are you doing today? A very warm welcome to my channel, and the topic of this video is Introduction to NumPy Arrays. So NumPy arrays are extremely powerful, widely used and most popular library for doing computational work, which include data analytics, data science and machine learning. If you are planning to use Python for any of these things, you may end up using NumPy library, and that's why knowing it is extremely useful as well as helpful. So by the end of this particular video, you will have a clear picture on what, when, how and why of NumPy arrays. Okay. Whenever we start learning about NumPy, one question creeps up. The question is, why NumPy arrays? Why can't I use the Python inbuilt list, or for that matter any other data structure? A perfect question. So during the course of this particular video, what I'm gonna do is that I'll do the same thing both with Python arrays or list as well as using NumPy arrays, so that you can yourself see what is the difference between these two and how one ranks as compared to other in various scenarios. Before starting, let me tell you the agenda. These are the 4 topics which we are gonna look into in this particular video. But before starting on to the first topic, let me tell you one very important thing about NumPy arrays. To show that, let me create a Python array with 1, 2, 3, 4, 5, 6, for example. And let me create a NumPy array. So I'll say it as NumPy array np.array, and I'll put a list in there. So this is the way we create a NumPy array. Let me go ahead and print it. I'll print PyArray as well as NumPy array. Okay, so you can see the list is printed over here. But one thing we should consider about NumPy is that NumPy takes data type. Okay, so by default in this particular case, since all are integer, it will implicitly give you an integer data type, but we can define the data type. For example, in this case, I want to define the data type as numpy.int32, for example. Okay, so there will not be any difference in the output. You can see the output remains the same. But there is one difference between Python arrays and NumPy arrays. So in Python arrays, I can create array of multiple types. So here I have included hello world. So as you can see, nothing will happen and the output will be printed accordingly. But if we do the same in here, it will result in an error, because most of the time there is a data type associated with NumPy arrays and it has to be homogeneous. First difference between NumPy arrays and Python arrays is that NumPy arrays are meant to be homogeneous, which means each element of the array will be of same type. The reason for this is that NumPy arrays are mostly used for mathematical calculations, and it happens if and only if all the elements in the array are of same type. We are not gonna mix and match these things in NumPy arrays. So that's the first and very basic difference. Let's start with our other topics. So to understand the memory stuff, let me just go back to the original one. Okay, this was my original array, and I'll just cut it and paste it over here so that we know which topic we are talking about. Okay, so when we have allocated array of same length for both Python array as well as NumPy array, we should know what is the size of these two arrays. So let's see the size of Python array. To calculate size of Python array, we will be using sys.getSize of one integer into len of pi array. So length gives number of elements. And for NumPy array, what we will do, we'll say NumPy array dot item size into NumPy array dot size. Size is equivalent to length, so this size will be 6. Okay, so let me go ahead and print it. See the difference of memory occupied by NumPy array, which is 48, and Python arrays, which is 168. Considerable difference. So if difference is not intimidating, I can do further optimization with NumPy array. As we have seen that we can put data types, we can say NumPy dot int, I can say int 8. Let's say I know that none of my element will exceed 255. Data type is int 8-bit integers. See the difference. Now the size remains as 6 bytes. So it's a huge difference, huge saving in memory as compared to Python list. That's the reason we should use NumPy arrays for storing large amount of data. So in case of data science and mathematical computations, we'll mostly be storing matrices and tensors, which are large set of data. And if we store those data in NumPy arrays, the amount of memory taken by the storage will be very less as compared to Python lists. And the memory saving is not limited to integer. Let me create a floating point variable or floating point list. So I have created a floating point Python list, and I am creating a floating point NumPy list, and data type I'll say, let's say it's float 64. Okay, so let me go ahead and run the program. You can see that still it's say 48 bytes and it's 168 bytes, still huge difference. Same thing is also applicable if you are storing the string, but I don't think you will be storing string quite often while using NumPy, but there is a savings in string too, and the more number of strings you use, the more savings you get. So that's the reason why we talked about the storage aspect first. NumPy wins hands down over here because NumPy takes extremely less amount of memory as compared to Python arrays. Okay, now after the storage, let's move to our second topic, which is creating n-dimensional arrays. So n-dimensional arrays can be created using Python list also. So let me first create a Python array at n dimension. Let me create a 2 by 5 matrix with 2 rows and 5 columns, 6, 7, 8, 9, 0, and let me arrange it in a way so that it looks like a 2 by 5 matrix. Similarly, I can create a NumPy array with this similarly 2 by 5 dimension. So I can say np arr equal to numpy dot array, same as above, and I'll just push this like. And now let me go ahead and print the both Python array and NumPy array just to make sure that there is no syntactical mistake. It happens when we try to print multidimensional arrays. Okay, so here I go and I am able to print 2 by 5 matrix for both NumPy array as well as for Python array. Now apart from space saving, there are certain additional things which helps us when we use NumPy arrays. The first thing is that we can change the shape of the matrix at any point of time using reshape command. So I can say reshape it is 2 by 5, I say make it 5 by 2. Let me go ahead and print and see what happens. The matrix is now changed into 5 by 2 matrix. So we can change the shape. It doesn't change the original matrix but generates a new matrix which we can use. So it's a very important functionality. If you want to transpose a matrix or change a matrix, it cannot be done with Python arrays. Not only this, we can generate numbers in case of NumPy arrays. So let's assume that we have to generate number 0 to 10. We can use a function called arrange and say generate me 10 numbers. Okay, let's see what this guy does. I'll go ahead, clear the it and generate. It generated me 10 numbers 0 to 9. Okay, I can also ask him to generate 10 numbers from generate numbers from 5 to 10. Okay, so it generated number 5 to 9, and I can even take the step as 0.5, a decimal step. Okay, so in this case it will generate a number 5, 5.56, something like that. So for example, if I want to generate number 10, 0 to 9 like this, let me go ahead and just print it to make sure that it's generating 0 to 9. I can change the shape. So for 10 number, I can say 5 by 2 matrix will be 10. The matrix, the multiplication has to be number of elements. So it's say 5 by 2. Okay, 5 row 2 column. I can even say 2 by 5. Okay, it's a 2 row 5 column. It has to match the multiplicity has to result in the number of elements. Otherwise, it will give an error just like over here. Okay, so this is the way we can use the arrange function. Now in this particular case, we have generated a 2 by 5 matrix from a single dimension matrix, right? NP array is a single dimension and we have generated 2 by 5 matrix. So I haven't saved it. Okay, but it's also possible to go back to single dimension from any dimension by using a function called ravel. So if I use this function, you can see that all matrices will be converted into a single dimension matrix. So any x by y matrix, n by m matrix can be converted into single dimension by using ravel function. Okay. Now there are two important functions in NumPy which actually helps us a lot. So these two functions are called zeros. Okay, and I can say let me generate 10 zeros. Okay, so I'm generating 10 zero, it generated me 10 zeros, and I can also say instead of 0 generate me ones. Okay, so in this case it will generate me 10 ones. As you can see that it is generating the decimal numbers. We can change the data type as int d type equal to np dot int 32. In this case it will generate integer numbers. Okay, and again I can change the shape of it. I can reshape it at 10 numbers as 5 2, and if you go ahead and print it, you can see there is a 5 row 2 column. Okay, we can change it like this. So zeros and ones are very useful in creating so-called sparse or dense matrix, which is used for various calculations in graph theory, and that's why these functions are extremely important. You can also create without any 0 or 1 by saying empty. Okay, but in this particular case the generated number will be undefined, so it can give any number as part of it. So that's all about creating n dimension arrays. So let's move to our third topic, which is mathematical operation. This is interesting. So let me create a pi array as 1 2 3. I'm using small array, and numpy array as np dot array again 1 2 3. So let me print both of them, pi a array and numpy array. Okay, and I'm just go ahead and just print it to make sure there is no syntactical mistake. No. Now let me multiply this by 2 and all this also by 2. What do you think will happen? You'll be surprised to see that when you multiply Python array by 2, it creates the duplicate copy of it and append it to original one. And while NumPy array actually multiplies the element with number 2. Similarly, you can do sum over here, and NumPy array will sum the elements. But sum with Python array is not possible because it will not treat it as a sum. It will treat it as something else. But I can do 1 2 3 like this. Then the end result will be same. Okay, that what we get with multiplication by 2. So you can see that mathematical operations are directly applied to the arrays, which is what happens in real mathematical world. Remember matrices, if we put a number outside matrices, that means the matrix, each of the matrix element will be multiplied by that particular number, and that's the reason NumPy arrays are extremely useful in doing mathematical operations. This is true also for the multidimensional array. So for example, if I create two numpy array 1 and 2 with two dimensional array, and if I just print the multiplication of these two arrays, so let's see the result. You can see that the multiplication result in the matrix of same dimension and with the multiplication applied on that. Not only this, there are other mathematical functions which are very useful. For example, I want to print square root of each element of numpy array 1. Okay, let's go ahead and see what happens. You can see that it's square root of all the values over there. Okay, numpy array 1. And along with the square root, there are other functions like, for example, mean or median or min or max. Let me go ahead and print it. You can see that mean is 3.5, median is 3.5, minimum number is 1, maximum number is 6. So these are the things we can achieve without writing a complex for loop in Python arrays. Okay, that's why these mathematical functions or mathematical operations are USP of NumPy arrays. Now let's go ahead and look into our last topic, which is about finding elements in the arrays. So let me create a NumPy array with numpy.array, and let me create 1 2 0 4 5. Okay, and let's assume that I need to find numbers which are greater than 2. I can use numpy dot where, and I say mp array greater than 2, and let me print find. Okay, find returns a tuple. Let me see what it returns. It returns a tuple, and if you say find 0, you'll find 3 and 4. Index number greater than 2 is 3 and 4. Okay, these are the index 0, 1, 2, 3 and 4. So if I say greater than 1, you can see it says 1, 0, 1, not 2, 3 and 4. Index 1, 3 and 4 are greater than 1. We can also say something like what all elements are non-zero. For example, I can say np.non-zero, and let me go ahead and print the find output. It says 0, 1, 3, 4. Index 2 is not non-zero. I can even say count non-zero. Okay, and if I do that, uh, I don't have to do, it doesn't return a tuple, so I don't have to do find 0. I'll say clear and I say 4. 4 elements are non-zero. If I change one more at 0, you'll say 3 elements are non-zero. So this number of 0 and non-zeros are extremely useful in situations like calculating the sparsity or density of a particular matrix. So these are the main finding functions which you are going to use. So that's all about NumPy arrays, guys. I hope I was able to explain the basic working of NumPy. I hope you have liked it. If you have any comments, please do write in the comment section, and do not forget to like and subscribe. Thank you. Thanks a lot. Thanks for watching.